Hello everyone, I'm Jacob Kaufman, I'm the nerd on the street, and today we are building a ZFS storage array inside my Arch Linux desktop. Okay everybody, right behind me here I have 3 Western Digital Red 8TB hard drives. That is a total of 24 terabytes of storage, and today we are going to be unboxing these hard drives, putting them in my desktop computer, and setting up a ZFS pool. We're going to set it up in RAID Z, which means we'll have 16 terabytes of storage, and any one of these drives will be able to fail at any given time, and I will not lose any data off the pool. Now, why the heck am I doing this today? Well, I've got about 12 terabytes of data that is irreplaceable, just stuff that I've accumulated over all the time I've been using computers my entire life. 12 terabytes of data that is currently sitting in a box on my floor, not backed up at all whatsoever. I have exactly 1 copy of everything. There is some stuff that is replicated across a couple of the drives on a folder per folder basis, but for the most part, if any one of the drives in this box I've got fails, and I'm looking at it right now, I'll show it to you later, I would lose a whole lot of data and never be able to get it back. And it's not like it's stuff that's actually super important, but it's stuff that I like to have. I like to keep everything that I make on the computer. I'm a digital hoarder since it takes up very little physical space compared to regular hoarding, which I also am a little guilty of looking around my room right now. But yeah, this is not necessarily a Nerd on the Street project. I bought this stuff with my own personal money. This is kind of a personal project. Obviously very technical though. I wanted to show you guys because we're going to be getting ZFS working on Linux. And if you haven't heard of ZFS, it's a very popular file system, and in addition to being a file system, it also takes care of other things like RAID and actually even some lower level stuff that file systems don't normally do. And ZFS is very popular in BSD, and if you watched my video a little while ago trying out FreeNAS, which is based on FreeBSD, I tried out that NAS program with a ZFS pool setup, and I was extremely impressed at how well it worked. Now, I actually priced out a FreeNAS box for myself. That's what I've been planning to build for a long time. And I think eventually I will still get one of those. For right now, I didn't want to spend all of that money on building basically what's just going to be another computer just to house files. I don't have the money laying around to do that right now, and I don't have the space for another computer or the network to really access a NAS over right now. But at the same time, I do have a little bit more money now since I'm working full time, and I have been getting more and more nervous as the years have gone on about all of this data that I have not backed up. I actually kind of got a kick in the butt to start this project talking to somebody at a St. Louis YouTubers meetup that I was running a few weeks back, and they asked me what my backup strategy was. And I got to sit there and explain to them how I don't really have a backup strategy. Once I get done with the video and upload it, obviously in the context of YouTube, YouTube's backing it up, Google's backing it up, and I've also got it on Dailymotion and Vimeo. But in terms of my personal files, like I said, 12 freaking terabytes of data that is, bits and pieces are redundant, but for the most part, it is just not backed up. And I've been extremely lucky. So far my entire life, I've only had 1 hard drive fail, and when that happened, I only lost 1 file off of it. So before I tempt my luck too much further, we're going to go ahead and build this ZFS pool. We're going to copy all that data onto this ZFS pool, and I'm going to have another 8 terabytes or so free on that thing. Or I guess another, probably 8 terabytes, because all these drives that I've got aren't entirely full. So there will be room for expansion here. So like I said, I picked up 3 WD Western Digital Red drives. The Red is their line specifically for network attached storage systems, and even though this is not technically going to be network attached storage since it's going on my desktop there, I still picked up the Red line because it's got a slightly slower speed, which does make it a little more reliable in the long term, and it also is made to run with several drives sitting right next to each other. The vibrations from one drive will not interfere with the vibrations for another. In the past, I've always gone for performance with hard drives. I used to use WD black drives, and those always perform great. They're loud as heck though, and they're not meant to be used for network attached storage or storage arrays, because if you put more than one of those next to each other, then the vibrations start to interfere with each other, and that increases your risk of failure for your drive. Obviously with something like this, I'm using RAID with parity striping my data with parity, and I'm using several hard drives. My primary concern here is safety of the data. Secondary concern is how much storage I have. And tertiary, in this case, is performance. That's why I'm going with WD Reds. Now, anyone who's built a NAS before knows you're not just supposed to pick up 3 hard drives off the shelf at the store and build your NAS, with 3 drives from the same batch. Because if you get 3 hard drives that came off the assembly line at Western Digital right in a row, chances are when one of those fails, the other 2 are not going to be long behind. Whether it's a manufacturing defect or it's just the fact that they've been on the same planes and boats and trucks getting shipped around the world to wherever they are. If you pick up 3 hard drives and the serial numbers are very similar to each other, it's just statistically kind of likely that they will fail near the same time. And that's dangerous with RAID, especially with parity RAID like we're doing today. Like I said, I'm setting this up with RAID Z, which is basically an improved version of RAID 5. It's RAID 5 with some improvements that actually makes it slightly safer and closes up some possible bugs in RAID 5 that can lead to losing data. But like I said, it's striping with parity, which it's actually a pretty neat way the way this works. We're going to have 3 hard drives, and when we start to fill up 2 of the hard drives, then the third one is going to take a mathematical output of adding together the data on the first and second drive to get this output on the third. It's real simple math, and I'll go into this a little bit later in more detail maybe. But if one of these drives were to fail, then basically your computer uses the working data plus the mathematical output, and it says, what was that other data to make this mathematical output? For this to be true, if this is true, then what does this need to be? And it rebuilds your data on the new drive after you replace the failed hard drive. Now, if while your computer is rebuilding that failed drive, reading the parity and the good data and rebuilding the failed drive, if another one of your drives goes bad, then you've just lost data. Probably all of your data. Although ZFS actually rebuilds in a safer way than RAID 5 as well. RAID 5, if 2 of your drives fail at the same time, you lose absolutely everything. RAID Z, if you're in the middle of a rebuild and something fails, you will actually keep everything up until that failure occurred during the rebuild. And RAID Z's rebuilds are also safer because it only rebuilds portions of your hard drive that actually contained data. It doesn't rebuild the empty portions. Whereas RAID 5 by itself would rebuild every single block on your hard drive, which is going to stress the drives a lot more and increase the risk of multiple failures happening at the same time. All of that goes back to the unboxings, which I'm trying to get to. I can talk about this while I'm doing it, but I'm just trying to get into the video here because my intros can get very long, I know. So basically what I did want 3 of the same model of hard drive. For simplicity's sake in this case, you can definitely do this with completely different brands of hard drives, and that's honestly probably safer. But what I did was I picked up 3 of the same model hard drive, but I ordered one of them from B&H Photo Video. I ordered one of them from Newegg here, and then I drove downtown into St. Louis, actually Brentwood, and picked up the third one from Micro Center. So we have 3 Western Digital 8 terabyte RAID drives that came from 3 different locations. B&H in New Jersey. I don't know where the Newegg warehouse that this came from was. Looks like California actually. And then St. Louis. So 3 separate places. They have not always been in the same location at the same time, so temperatures have not been the exact same with them. I will compare the serial numbers just out of curiosity when we do open them up to see how close the serial numbers match on all these, how far away they were on the actual assembly line when they were produced. But at any rate, we have, at least by doing this 3 separate locations for buying the hard drives, we have lessened the risk of several failures occurring at once down the line with this pool. So without further ado, I do want to get into the video here. The ZFS stuff is going to be screen capture, and I'll get to that a little later, but first we obviously need to unbox these hard drives and then put them into the computer. Alright, and here we are on the desk, but I did want to do a complete unboxing of these, showing you what actually came in the shipping boxes in case you're curious what the differences are between the different retailers. I know I've done Newegg hard drive unboxings before. One time they just sent me a hard drive wrapped up in some bubble wrap in a box, and that was, I felt safe actually the way they did it. But just in case you're curious, this is the Newegg box we were opening up first, so we will do this, slice into the box here. The retail boxes, since all 3 of these I believe were retail packages, they should be pretty much the same since this is the same product we are unboxing 3 times. And this project was, it was not super cheap. But on the other hand, this was like a third or a quarter of the cost that actually building an entire NAS would have cost. So this is a great stopgap measure, and then in another half decade or decade, I can reevaluate if I want to continue with the NAS. All right, so Newegg, looks like they threw in some coupons here. HelloFresh. Normally B&H does this stuff, or I guess Monoprice does this stuff. I don't remember ever seeing other coupons with Newegg, but yeah, trying to sell me accounting. Great. So we had a little bit of, bubble air pockets in there, another one down here. And then in here, we've got a brown box, which that's everything in the Newegg shipping carton. So we'll throw that down onto the floor. And if we open this box up here, actually, let's take a look around first. Okay, this is a serial number for this red drive. And if we open this, this is just the hard drive in plastic. Okay, so see, years ago I ordered a Seagate drive from Newegg, and they actually sent me this, like I said, wrapped inside a bubble wrap and then stuck into packing peanuts. This actually seems a little bit less safe since this is just hard plastic here, and the drive is just sitting in here. This one did not come with a SATA cable. That's fine. I do have SATA cables that came with my computer. I actually wired the computer up for SATA when I was building it because I knew, future expansion would occur. So this is what you get from Newegg when you order a red drive. It just comes in a box in some plastic trays. We'll throw that box down there. And here is the anti-static bag with a sticker on it, Western Digital 8 terabyte. You can see there. We will take the trays off. And as you can see, this says moisture barrier bag. In addition to stopping static, it's also good for other reasons. We will open this up, airtight obviously, since it is a moisture barrier. We will just tear that open, and let's see what this drive looks like. I believe these 8 terabytes, oh no, that actually looks normal. The pictures online of the 8 terabytes and 10 terabytes looked very different from the 6 and below. Because the 8 terabytes and 10 terabytes, at least, I don't know about the smaller ones, but these larger Western Digital drives actually have helium, I believe, inside of them. It's either helium or nitrogen. I think it's helium. Sealed inside of this drive where the platters are to actually reduce the amount of friction that the head has against the platters, and that makes the drive run cooler. It makes it take less power, and also theoretically by doing those things, it should make the drive last longer. You can see it says here NASware 3.0. That's part of what I was talking about, where the firmware on this drive is actually built to detect the vibrations that are coming into it and account for that when it's reading and writing. You can see this is a 6 gigabyte per second drive, even though it is a 5400 RPM drive, as opposed to faster drives, which are going to be 7200 or 10,000 on the crazy ones. So that is the first drive, and we'll see what the serial number is here, VAGJ1GSL. So we'll compare the serial numbers, like I said, once we have these all opened up. But yeah, that drive looks very normal. Like I said, the pictures online made it look like the 8 and 10 terabyte versions of that were a lot more, I don't know, futuristic and different looking. But I'm fine with a classic because that's what I'm used to. So here's the B&H box. Let's see, it might just literally be the same thing, or it might be completely different. So let's see here. That's why I'm doing the unboxing, is to show you. So we'll open these up. Set the knife off to the side again. Okay, it looks like we do have very similar, oh, not quite exactly the same. Also large air packets. Nobody uses the small bubble wrap anymore. It's always these huge things, but looks like we got 2 layers of that or so. And then B&H actually gives us the retail box, which is nice. This is the B&H packing slip, which includes my address, the last 4 numbers of my credit card, and other things I don't need you to see right now. So that's going to go off screen. And in here, so yeah, Newegg really likes to just send out bare drives, which honestly is probably better for the environment if they don't come in Newegg to these drives. If Newegg's just opening them up, that's just kind of stupid if they're just throwing the cardboard away and sending out bare drives. But if Newegg gets them in bulk, then it makes sense economically to ship them out as bare drives. Because I don't think there's anything extra in here like cables. I think it is just the drive itself, which we'll check right now. But this is what the retail box looks like for the WD Red 8 terabyte. So you can see very plain packaging on the sides, the back, RAID optimized environments like NAS systems. So like I keep saying, this is not a NAS I mean, it isn't, I mean, it's kind of a NAS because my computer is connected to the network, but this is a RAID pool that we're setting up within my desktop. It's an internal RAID pool, which is going to be neat, but it is very similar to a NAS with the setup and everything. We got sticker on the bottom. On the top, we've got some tape here, or a seal to cut. We'll just slice that. And how do we get this thing open? I think I'm doing it right. I think there's more tape. There we go. All right. That's easier now. Okay, and then here we've got also plastic tray. So even Western Digital in their own box doesn't include actual bubble wrap. So this comes with a little bit more though. Newegg did not come with any screws. B&H sent us the retail box, which comes with 4 mounting screws. Now I think my computer case came with mounting screws as well, and yours probably did too if you built your own computer, but it's nice to have mounting screws. I'm gonna set the retail box off to the side. We do have some warranty information here, which once again, this is the kind of stuff, like I'm not gonna read this. I don't care that Newegg didn't include this stuff. Quick install guide for internal hard drives in case you don't know how to install, which is nice there. And then, so Newegg had the plastic trays at the top and bottom of the drive. Western Digital in the retail box puts it on the left and right, covers more surface area, I guess. This plastic is also, it's hard plastic, it's not like soft or anything. It is softer, it's not quite as hard. Almost feels like a plasticky foam type thing there. So when this is getting jostled around, it might provide a little bit more flexibility. And then here, this is a slightly different looking, oh my, okay, so see, this is what I was talking about. This drive actually looks entirely different. Which is actually a great thing. That's actually good because that means these are not from the same batch. Like I said, the more different these are, the better, because that means when one fails, the other won't necessarily be close to failing. But this is the translucent type of anti-static bag that you'll commonly see. This one was completely opaque, but this one, you can see through it a little bit into the drive itself. This sticker's not on the bag. This sticker's actually on the drive. So we're going to tear this open and look at what this drive looks like. Leave the end connected there, and here's the super duper fancy futuristic looking drive. Look at that. Now the drive that I showed you before, I've seen hard drives like that. All my hard drives look like that. I have never seen a hard drive look like this before. Look, they got the sticker going all the way to the edges here, and you just got this smooth metal at the top and bottom. The back looks the exact same as a normal hard drive, which is reassuring, I guess. Top of it, sides look the same as a normal drive. The bottom does too. Okay, so it's really just the front that looks different. So I don't know if that one actually has the helium in it or not. This one definitely does. It's sealed with the helium. And this is the design they use just for the 8 and 10 terabyte versions. Like I said, if you get the 6 or below, it's going to look like that other one from my understanding. So this one should be a little bit newer. Oh, these actually, you know, drives are always dated, so we can check that too. So the serial number on this thing starts with 7HK, it's 7HKBNX9F, so that's completely different serial number. Once again, that's great. This is the model number, and then this was manufactured in December 2018, did I see somewhere? 26 December 2018, that was the date that this drive was manufactured in the factory, which it's really neat that they put the dates on there. It's always nice to be able to tell. Let's take a look at Newegg's drive they sent us and see what the date was on that. So WD80EFAX. So the model number is the exact same on these two drives. These are the same thing functionally, even though they look so different. They are the same thing functionally. But this is the more traditional design you'll see on internal hard drives. And this was 12 September 2018. So this was manufactured 3 months prior to this. Maybe that's when they switched the design. Or maybe there's another reason for the design difference. I don't know. NXHA500. Yeah, the rest of the model number is also the same. Interesting. So yeah, this is the comparison between the old style and the new style. New style, obviously, you know, it's cool. It's futuristic, simple, sleek. The old one worked perfectly fine as well, and I've seen it many times, and I'm comfortable with it. So you can decide for yourself which design you like better, but you don't really get to pick since, like I said, these are the same model number, and one of them looks one way and one of them looks the other. So there's really no way you can tell. In the Newegg pictures, I'm pretty sure it looks like that on their website. So you get what you get when you're ordering these. So I'm going to put these back into their bags once again. So we had a September 2018 drive, and we had a December 2018 drive. And the last one we have to open up is the Micro Center one that I picked up here in St. Louis. I'm actually very interested in what the date's gonna look like on that one, because I was interested. I wasn't sure if the St. Louis one, that I got locally was going to be newer or older than the ones that were shipped to me. Because on the one hand, it's closer to me, and usually local stuff is fresh and new and whatnot. But on the other hand, I can see Newegg and B&H, these huge companies shipping out so many orders every day, having more optimized product flows than maybe a retail brick and mortar shop. So this is the same box, but it's dirtier. I don't know if you can tell on camera. It's especially apparent on the back. Look at the left came from B&H and the right was Micro Center. And this was in a locked shelf at Micro Center. It wasn't like this was out where people were touching it, but it's just that dirty from being stocked at Micro Center. Yeah, you can definitely see that a bit on camera. But aside from the dirt and the extra stickers that Micro Center stuck on the front, it is the same box. I will also be interested to see which one of these does fail first. Obviously, I'm not expecting any one of them to fail in the near future at all. However, if, say, the Micro Center drive fails years before the other two ever fail, then I'll know to not buy drives at Micro Center anymore. Since these are the same drive and all that, we're kind of getting a peek into how the stores handle the drives as well, buying 3 of them at once here. Just all kinds of interesting stuff happening with this project. So trying to open this, there we go. And we'll see what this looks like, if it's the new version or the old version. Looks like we got the same documentation. We also have the same 4 screws in there that I'm not going to take out. I showed them to you close up already. And here is our trays. Turning this around right now. All right, we've got another one of the new version. So Newegg was out of date with the old style hard drives, and then B&H and Micro Center both had the new style. Good to know where you want to go if you're looking for the most up-to-date tech. Newegg used to be my go-to. I still prefer Newegg over like Amazon most of the time, but I really have been ordering from B&H more and more, even with general computer stuff, and I have been going to Micro Center quite a bit, even though Micro Center actually does mark up a little bit for being a brick and mortar store. So this one, 7S, as opposed to 7H. So both the serial numbers start with 7, but the second letter of them, or second character, is different. And this drive from Micro Center was manufactured January 16th, 2018. Wow, that is really interesting. Okay, so this was January 2018, assuming all these are printed correctly. So this was the beginning of 2018, and it was the new style. Newegg has one that was September 2018, and it's the old style. And then B&H had one that's the end of 2018, and it was back to the new style. So clearly Newegg's not getting outdated stock. I don't know how they decide what's going to get manufactured with this new casing, with the new front, and what goes with the old front. But yeah, that is very interesting, but also very good. Because that does mean that my plan worked, even though some people would yell at me for getting 3 of the same drive at the same time. At least I can verify that these were all manufactured months apart. January, September, and December. And you know what? Now that I'm looking at these a little bit closer, I noticed that the layouts for the labels on here, I'll put them in chronological order here. The labels are actually slightly different on the January versus December ones. At the bottom right there you can see they both have the QR code there, but some of the logos moved around or changed. And the date was printed here on the January one, and it's over here more on the left on the December one. So they changed around. Oh, and this says 8.0 terabytes, and this one just says 8 terabytes. So yeah, they're modifying how the stickers look, changing up what bags they're sending them out in, changing up what the front cover looks like, but the model number is exactly the same on all of them. WD80EFAX, the exact same on all 3. So that is, yeah, very interesting. It's not very often you get to order 3 of the same thing and compare. So most people, when they open up just one of these, they're not going to notice that little stuff. Even if you watched an unboxing or something, you're unlikely to remember that your unboxing had a 0.0 and yours does not. But this is kind of neat, seeing them all lined up. So yeah, this is what the drives came as. This is what they look like. I'll take them out so we have a nice thumbnail for the video, and then I'll just set them straight on the desk. This is a wooden desk. The drives should not get damaged by sitting on the wooden desk for a couple seconds here. Okay, so here's what we're dealing with today for this project. Very cool. I am very excited about this. I am going to stop the camera now, and I'm going to regroup a little bit, move things around so it's easier to get into my computer. I'm also going to have to switch to my laptop for audio recording because we are going to have to turn my computer off when I plug these things in, since I don't feel like hot plugging into SATA the 3 brand new hard drives I just got into my high-end computer. We're gonna have to shut it down when we do that. So I'll be right back, and then we will install these things, and then later we'll get into the software side of it, setting up the ZFS pool. All right, guys, that wasn't too bad. I do have my computer on the desk here, turned around and ready for us to install these hard drives. So I am going to take the cover off. I did flip it around. The side facing away from the glass is where I believe we put hard drives in. At the very least, it is definitely where we plug hard drives in. So we are going to have to remove this side of the case. Taking this off right now. Okay, and I was correct. This is where we pull out the trays. I'll set this cover down off to the side here. So we're going to put these hard drives basically as far away from each other as they can go physically, just so that they don't interfere with each other too much, even though they are designed to be able to handle several drives in one case, the vibrations and whatnot. We still want to minimize any impact we could have from that stuff, as well as heat. You know, there's a fan right here in the front of the case. I want to still allow as much air as possible through to the rest of the components. Since these hard drives are not going to be super heavily utilized, honestly, it's more like warm storage. But this computer also has several high-end graphics cards in it. It's got a really high-end processor. And that stuff I do tax very heavily when I'm doing things like animation, so I need to make sure that airflow is not obstructed. And in fact, now that I'm looking at this, what I think we'll do is put the 3 drives in these bottom 3 slots. I know I just said we were gonna put them as far away from each other as possible, but now that I actually look at this, I really do care more about cooling the rest of the case than these drives. So we are gonna stick them down here in these bottom 3 slots. That way the top 3 slots with the fan still unobstructed. Heat rises, so hopefully the drives, you know, down there, they shouldn't be burning or anything, especially since, like I said, these things won't be used that heavily anyway. They'll just kind of be there, and I will write to them occasionally and read from them occasionally. So we'll put these in one at a time here, taking the first one out of the bag now, and I'll try and, you know, not obstruct our view too much here. Taking the bottom tray out of the computer now. This case does have trays that are fairly easy to use. For hard drives, it does not require any sort of screwing at all, which is exactly what I looked for when I was selecting a case. We've got a little tag here from a cord that came out of our case that was attached to one of these wires in here. We'll set that off to the side, and we will put our hard drive in. So here's what this is going to look like. The drive is going to go in here. You can see there are these little plastic pieces in here, plastic extrusions that are going to hold the drive in place, basically sticking into the screw holes in the drive. And in order to open this tray up, we just take the side of the tray here and we pull like that to open it up. So on the other side now, the rubber is sort of, it's not falling out, but it is a little bit loosened in there. And yeah, we'll do that again on the other side, just like this. Okay, and now we can put the drive in. So lining up these 4 screw holes on the bottom side of the drive there on either side, those are going to be lined up with the rubber pieces in the tray. Trying to get a decent angle of this, and we'll pop that in. Okay, so once the drive is in place and you've got it, you know, in the tray where you want it, at this point we just pop these plastic pieces back in on both sides. All right, took a little bit of force to get the last one in there, but at this point all 4 of the plastic bits are on the hard drive, so we can hold this tray, you know, and the drive is within the tray. So it's in there now. And of course, you're not going to be moving your desktop computer around a whole lot, so this doesn't need to be super sturdy. It just needs to hold the drive in place so it's not shaking around when it's working. So we will slide that tray back into the computer there. All right. And at this point, we need to plug that in. I'm just going to put all 3 drives in first, then I'll worry about plugging them. Here's the next drive. We'll put the different looking one in the middle. Like I said, it really shouldn't matter which one goes where too much, unless they have radically different heat output. But we'll pull out our second tray here. I'm not going to bother going up close to the camera for every single one of these. It's the same process, and you guys have seen me install hard drives into computers before. I did just want to include you in this part of the process though, since this video is kind of covering this project from start to finish outside of planning. All right, second drive is in the tray, and pull out all these cords that I had shoved into these trays for cable management for a second. Slide the second tray back in, take the third one out, open it up. And here is our third and final drive. There we go. All right, and we'll slide the last tray in like so. So now we just have to plug in the 3 power adapters there, power connectors, and the 3 SATA data connectors on the right. And I don't remember how many plugs I ran. Do we have 3? Yes, we have 3. Okay. Looks like we have exactly 3, so that works out perfectly. I was not planning this project when I built this computer, but I am glad that our numbers are matching up. So we're going to plug in each of these SATA cables. We'll do one of the downward facing ones on the top 2 drives. 1, 2, and then we'll plug the straight SATA cable into the bottom drive. Really doesn't matter which SATA cable goes where. It will affect the order that the drives appear to the computer, you know, the EFI and everything, based on where these are plugged into on the other side on the motherboard, what ports these hard drives are plugged into. But ZFS is going to combine these all into one storage pool anyway, so I'm not too worried about what the drives are actually called to the computer. Okay, and the last thing we need to worry about is power. Looks like we've got 2 SATA power connectors right here on this cable. Just kind of grabbing whatever power connectors are available here. So we'll plug these in. All right, I definitely liked the trays in my old desktop better than this one. This is a very nice case, but the hard drive trays in this one, since the tabs to pull them in and out of the computer case are on the same side as the plugs, you kind of have to fight around that tab when you're plugging in the power. Obviously not going to matter at all once we're finished, but just for the build process here, it's a little annoying. We're fine though, and we'll plug in one of these SATA adapters here, power connectors, if we can get one to reach. There we go. Perfect. So there is our third SATA power cable plugged in. So at this point, the drives are all wired up right there. They're in the computer. I am going to put the side of the case back on now. I'm gonna spin this around, put my desk back together, and I'll be right back on the desktop and we'll do the software side of this. All right guys, here we are on the desktop, and I actually did already install a couple of packages for what we're going to do today. Now I'm on Arch Linux, and on Arch you can get the ZFS for Linux project through the AUR. Now ZFS for Linux is not as mainstream as it could be right now. It is, I believe, included in Ubuntu, or at least very easy to get on Ubuntu. Arch has the AUR, so it's easy to get here, but depending on your distribution, if you're using something like OpenSUSE or Fedora, it may be a little difficult to get this stuff installed. ZFS cannot be included in the Linux kernel like other file systems can, because the ZFS code is licensed under the CDDL, which, while it is a free software license as recognized by the Free Software Foundation, it is incompatible with the GPL, which the Linux kernel is licensed under. I'm not going to go into the details of the licensing situation today, but that is why this is a separate package we have to install, or rather several separate packages we have to install, rather than being included in the Linux kernel like any other file system should be. It is a licensing issue. Now on Arch, all I had to do was install ZFS DKMS. I am using the default Arch Linux kernel. I am not using LTS. I'm not using a specific old version. I'm using the up-to-date kernel. I do have ZFS DKMS installed from the AUR, as well as its 2 dependencies, SPL DKMS and ZFS utils. So ZFS utils is going to give us some CLI tools we can use to interact with ZFS. ZFS DKMS is basically it's a dynamic kernel module that will rebuild itself based on your current kernel version every time you update the kernel. I'm already using other DKMS packages elsewhere, so this was not a hassle to add for me. If you are concerned about that though, that's something to keep in mind, is that ZFS right now on Linux does require either using some specific versions of the kernel that are targeted by ZFS on Linux in their official builds, or using the DKMS build, which should automatically work with any kernel version, but as noted in the comments here in the AUR, sometimes there are patches required when you update certain kernel versions. Currently though, this was a one-click install for me. I did not have to apply any patches, manually at least. So if we open up a command line here, I did hear the hard drives power on when I turned on my system, which was kind of neat. They are very quiet. I had to actually reach into the computer put my head down next to it to hear them. And actually, before we even get into the CLI at all, let's just open up gparted and let's take a look at the 3 drives in gparted. We're not going to format them, but we are just going to take a look at them. So as you can see, we have our 1 terabyte NVMe drive, which is mostly used for this Arch install, and I still have 45 gigabytes of stuff left over from when I was using a different distro that I have yet to copy over. And then we have 3 8 terabyte Western Digital Red drives. You can see it reports as 7.28 terabytes usable. As hard drives get bigger and bigger, the percentage that is not usable stays the same, which means that the amount of actual space that you're not getting goes up the more total space the drive has on it. So 7.28 terabytes is a little bit less than 8 terabytes, but we do have SDA, SDB, and SDC all correctly named there. And then we also have dev SDD, which is another 1 terabyte hard drive. That is an external drive that I've got plugged in right now. As you can see, these 3 drives were inserted first in our naming scheme A, B, and C. Before I just rebooted the computer, with the new drives in, this drive SDD was named SDA. And even though right now this is SDA, B, and C for the 3 drives we just added, they could change in the future. They shouldn't change if we don't change anything, but depending on software updates and if we add any other hardware to the computer, it is possible for these naming schemes to change. So you're going to see me reference these drives by UUID in a few moments, as opposed to the dev name. So now that we have verified at least that all 3 drives are detected by our system, which is awesome, we are going to go ahead and start creating our ZFS pool here. The first thing we're going to do is enable a systemd target, which will start up the ZFS daemon automatically for us when we turn on our computer. I do not want to have to go and run commands every time I want to mount this thing, not complicated commands at least. So we are going to systemctl enable ZFS.target, and I'm going to enter in my password here. I could have ran that with sudo, but I didn't. So we have just enabled ZFS.target, and we are going to start ZFS.target to start up the ZFS daemon. This is another thing that if you're building a ZFS NAS, you're actually going to have to pay a lot of attention to what processor you're using, how much RAM you're using, because ZFS, since it does so much, compared to other file systems, ZFS actually does require more resources, more processing power, more RAM to run your storage. Now on this computer, if I open up my system monitor here, this computer, it's not going to be a problem because I've got a 16-thread CPU, 8 cores. I got 32 gigs of RAM right now, and that's going to be upgraded in the future eventually. So that's another reason why it was way easier for me to go ahead and just throw some hard drives into this computer. Even with this additional software running, this is more cost effective for me than having to build an entire other computer that could handle this ZFS daemon. We are going to go ahead and enable a few other systemd services. One of them is going to be ZFS import cache. And this is going to be used along with these next two, these 3 services I'm enabling. These will be used to automatically mount the pool on boot so that I don't have to go and manually mount it with the ZFS utilities every time I start my computer up. So we've got ZFS mount is the next one, and systemctl enable ZFS import.target. All right, and we will go ahead and start all of those as well. Start ZFS import cache, ZFS mount. Looks like we got an error starting that one. Failed to start mount ZFS file systems because the ZFS modules are not loaded. Okay, we'll get to that in a moment. We're going to run ctl start ZFS import.target. All right, so there is a kernel module as well that was installed by that DKMS package. Maybe if I do a sudo start ZFS mount, is it going to run the mod probe for me? No. All right, we'll just do a sudo mod probe ZFS. That's all you got to do to load the kernel module. And I did do this before, so I know that's going to work. And now we'll run. Oh, I ran a sudo on status and not start there. Well, we'll do a sudo systemctl start ZFS mount. Okay. So hopefully this ZFS mount will automatically start that kernel module for me so I don't have to do that manually. Yeah, I just messed up the command there when I was trying to see if systemd would start that kernel module for me if I ran it under root. But that's okay. So everything is started now to do with ZFS, all the daemons and everything we need. So at this point, I'll turn my font size up a couple clicks here, and we're going to run parted -- list to see a, oh, that was supposed to give us a list of all of our drives. If I run man parted here, yeah, -L is supposed to list partition layout on all block devices. parted-l. Oh, I guess we need to run it with sudo. That's the problem. Sudo parted-list. There we go. Okay. So we were just told what all of our disks are. As you can see, we've got SDA, B, and C. These are our three 8 terabyte WD REDs. This is the model number we saw written on the drives, and 2 of these say 68L, and 1 of them says 68K. I'm not sure if this K is the older looking drive or if it's the actual oldest drive or newest. It doesn't actually matter to us at this point. So we know right now on this boot, or on this, at this moment, the 3 disks we want are SDA, B, and C. We have verified that in gparted and regular parted here. Now we're going to run sudo ls-lh dev disk by ID. And this is going to list out our disks by UUID, the Universal Unique Identifier. As you can see here, we've got SDA, SDC, and SDB. These are the 3 UUIDs for those. And these are the strings we're going to use to actually reference these when we're working with them in commands. I know down here we also see pointers to SDA, B, and C with these other IDs, and we could actually use these as well since they point to the same destinations. These are just links, but we're going to go ahead and use the links that start with ATA since we're dealing with these as ATA drives. Okay, and at this point, all we have to do is create the ZFS pool by running zpool create. We're going to include -f to force creating the pool in case ZFS does not find an EFI label on the drives. We are going to specify the mount point for the pool with -m, and that mount point is going to be in my /mount directory. As you can see, I already have a couple of mount points that I've created manually. One of them is the SSHFS mount point to my Serval laptop, which I have made a video about in the past. But we will go ahead and make a directory here. I have started naming my drives, my external drives. The archive drives are just called archive, but as you can see, I've got my external hard drive here called Freelancer. I've got a flash drive called Beacon. I am going to name this storage pool Destiny based on the ship from Stargate. But you can obviously name your pool whatever you want. So we'll go ahead and create that, and we will chown it to Jacob. All right, so if I come in here now, we can edit things inside of this mount point. So when I run this command over here, we shouldn't get any permission denied errors. So our mount point now is going to be mount Destiny. The name of the pool is going to be Destiny. This is going to be a RAID Z pool. And once again, RAID Z is going to use one disk equivalent of parity. This is going to be very similar to RAID 5. And I kind of touched on this earlier, but I do just want to briefly explain how parity works for my viewers who might not be aware. Basically, we're going to have 3 disks, disk 1, disk 2, and disk 3. And how the parity works in a RAID 5 or a RAID Z setup is disk 1, we're going to put some data on. That could be a 1 or a 0. Disk 2, we're going to put some data on. It could be a 1 or a 0. And disk 3, I'm simplifying this a little bit, but basically disk 3, if these two are the same, then disk 3 is going to get a 0 bit. So that means if disk 1 had a 0 and disk 2 had a 0 at any given point on the disk 3 would also have a 0. If disk 1 has a 1 and disk 2 has a 0, these are 2 different values. So disk 3 is going to get a 1. And if disk 1 has a 0 and disk 2 has a 1, disk 3 will also get a 1 because these are different. Now this is a really smart setup because with just one extra disk, you're not having to mirror. You know, we could just have 4 disks and copy each disk over once. But instead of having to have a separate copy of 2 disks, we can just have 1 disk with the parity information for each of the other disks. You can tell that we're saving space because there are 4 combinations here, 1, 1, 0, 0, 1, 0, and 0, 1, but disk 3 only has to worry about 2 possible situations, 0 and 1. Are these the same or are these different? And this means that if disk 2 were to fail right now, let's say that that goes away and we replace disk 2 here with a new disk, we can very easily calculate, okay, this is a 0, so these 2 were the same. Disk 1 had a 1 in this position, so there's a 1 here on disk 2. There's a 0 on disk 3, so these 2 disks were the same at this point. There's a 0 at this point on disk 1, so this must be a 0 on disk 2. There's a 1 here, so disk 1 and 2 were different here, and disk 1 has a 1, so this is a 0. And there's a 1 here, so these 2 were different. This is a 0, so now this is a 1. And we have just recalculated, we have rebuilt this failed disk using the parity information. And of course, if disk 3 with the parity information goes bad, then we can just redo the parity information based on if these are the same or if they're different again. So that's how we managed to have 3 disks of the same size and have one storage pool that is the size of 2 disks, but we can lose any one of the disks and not lose any data. Quite clever, and we are going to use regular RAID Z. Now there are some people out there are probably quite a few people out there who are saying these drives are 8 terabytes and it is unsafe to use RAID 5 or RAID Z with 8 terabyte drives because those drives are so large, it's going to take quite a bit of time to rebuild a failed drive, and that's going to stress out the other 2 drives during the rebuilding. So there's a relatively high likelihood that a second drive will fail during the rebuild, at which point we lose data. My response to that is, a couple-fold. For one thing, the likelihood of losing one drive is already low. Like I said, I don't normally lose drives. I don't see drives fail very often. There are only 3 drives here, so the number of points of failure is pretty low. If one of those were to fail, I would want to stop using the other 2 and rebuild as soon as possible. But the likelihood, especially since I did get 3 different drives that were manufactured at different points in time, the likelihood that 2 will fail at the same time is very low. Additionally, this drive or this pool is going to be used basically for backup because I am copying off of some very old hard drives. I do want to have another copy of what's on those old hard drives because they could fail at any moment. But if this pool does fail in the future, I'm not throwing the old drives away either. So there's a chance I can still get data off of those. Frankly, the fact that I'm doing RAID Z rather than not doing RAID at all and just having a couple of really large drives in my computer, this is already safer than anything I've ever done in the past. So that's my preemptive response to anyone telling me that RAID Z is a bad idea. It might be a bad idea, but it can't be a worse idea than just having a couple of drives. Because the size of this pool is the size of 2 out of the 3 drives. And if 2 drives fail at the same time anyway, in the alternate universe where I wasn't using RAID Z, I would have lost all my data regardless. And RAID Z is also nicer to the drives while it's rebuilding. Like I said earlier, it only rebuilds bits that have been occupied by data. It does not rebuild empty sections of the drives, so that's a lot less read and write than rebuilding a regular old RAID 5 pool. All right, so with that out of the way, sorry for the brief interruption, which was probably annoying to anyone who already knew all of that, but I wanted to go through it. At this point, we just need to list the IDs of our drives. So we've got SDA right here, copy, paste, SDB right here, copy, paste, and SDC right here, copy, paste. This should be everything we need to create this pool. So we'll go ahead and run this command, and permission denied, okay. We are going to run that same command with sudo because apparently we do need root privileges for this, which does make a little bit of sense. And I just heard the drives all spin a little bit. Western Digital drives, it's normal to hear a little bit of sound from them while they're working. It was nothing unhealthy, but now we can run zpool status, and we've got pool destiny, state online, scan, none requested so far. And you can see our 3 disks listed here and no known data errors. ZFS will also periodically, or in its normal operation, it will actually check against the parity. It takes checksums of the data. It uses the parity from RAID Z to detect if one of the drives has bit rot, and it will automatically correct that for you. No user intervention or admin intervention needed, which is another thing I've been worried about with these other drives just sitting on a shelf, hardly being plugged in at all because I don't want to increase the risk of them failing. But now they're just sitting cold for long periods of time, and I have been worried about bit rot too. So this will be great. The ZFS daemon will just be checking it in the background for me. The one other thing I am going to do is disable access time. ZFS can keep track of the last time that you accessed any of your files in addition to the last modified timestamp. I don't need access time to be tracked, and that will create a lot more writes to the pool because it has to write the new access time every time you access something. So we are going to turn that off by running ZFS set atime equals off, and the name of the pool, which is destiny. Permission denied, so we'll run that again with sudo. Okay. And if we run zpool status again, all right, looks like the output's the same for zpool status. And at this point, if I open up that directory, root mount destiny here on my computer, and I look at our properties, you can see here device usage, 14 terabytes free of 14 terabytes. Like we saw before, we are losing a little bit of storage. It would be 8, 16, and 32 terabytes, but between the hard drive manufacturers rounding and ZFS's overhead, we are getting about 7, 14, and 21 total terabytes of usable storage 14 of which we can store files on, and 7 of which will be used for parity information. And the last issue is that this is currently not writable by me. As you can see, I can't make a new folder or anything. I'm just going to come in here and run sudo chown jacob mount destiny. Run that. Now if I come back in here, refresh this, now I can create a new file. Testing. We'll put some data in here. I'll just copy all of my terminal output actually from this video. Copy. And we'll paste it into this file and save that. Now back here on our mount point, still 0% used since this is a tiny file, 8.1 kilobytes. I am going to go ahead and start copying data to this thing now though. That's all there is to making a ZFS pool. And if any one of these drives were to fail, I could use the ZFS utilities to repair that. Now there is something called scrubbing that I will want to set up. I'm not going to set it up right now. Like I said before, ZFS will detect bit rot and write errors when you're reading from the drives. They will automatically detect if bad data is read. However, it is by default only doing that when you're reading data. Now there's a feature called scrubbing. If you're not reading all of your files all the time, but you still want to be protected against bit rot, you can have the ZFS daemon automatically traverse all of your files and do that check and automatically repair things that it finds that are wrong. You can do this manually at any time by running zpool scrub and the name of the pool, destiny, which it's going to be denied, but we can run that with root and you'll see it just scrubbed. There's only 8.1 kilobytes on this thing, so not much to scrub there, not much to check. It is very easy to set this up to run automatically. It's recommended to run it automatically every week, but you can have it run more or less often based on your needs. You can do that through standard Linux tools like cron or crontab. So I'm not going to cover creating that in this video because that is a little bit complicated to do with systemd and it's not really in the scope of what we're doing. Maybe I'll make another video about making timers with systemd. For now though, that's how you create a ZFS pool. Overall, it was pretty easy. Probably the longest part of this process was acquiring and installing the hard drives in the system. The ZFS daemon was a one-click install on my Linux distribution at least, and then all we had to do was run a couple of commands, and now we have this huge, safe storage pool. So that's it. Let me know if you guys have any questions about this in the comments down below on nerdonthestreet.com, YouTube, or Dailymotion. And if you found this video interesting and or it was helpful to you, you can always join the Nerd Club at nerdclub.knots.co to help me make more videos. For now though, that's everything I had to cover in this video. So I'm Jacob Kaufman, I'm the Nerd of the Street, and I'll see you guys in the next one. Bye.